And joining me now in studio, Satish Udpa, Dean of the College of Engineering. Dean, I watched that piece with Gabby Kleber, and I am amazed at all of the different things that engineers are doing these days.
You're absolutely right. The kinds of things that our students do these days are substantially different from what our students were doing just 10 years ago. And it's because of the nature of problems that society is confronted with on a daily basis. Several years ago, it was okay for students to do what we call routine engineering. Today, the kinds of problems that we face require our students to be familiar with a number of disciplines, not just one or two disciplines. So what you're looking at in that particular piece was a student who has to be familiar not only with environmental issues, but also ways in which we can combat pollution, for example, climate, a whole lot of remediation technologies and so forth. So students have to be familiar with a number of disciplines, not just one or two things.
Gabrielle talked about water and looking at those issues.
Right.
And if people out there, if you're worried about the safety of our water, rest assured MSU researchers are working on it. Of course, when you see just what they're up to, you might start to worry about the fish.
This lab has been established for about 60 years.
Behind these doors, in the basement of the engineering building,
Oh, I like the MSU.
is a room full of electronics, robotics, and a huge tank of water.
It's a large water tank. It's about 15 feet long, 10 feet wide, and about 4 feet high.
This is where you come to see your electronics take a swim.
All right. We do research on a number of things, from control systems to smart materials and to robotics. And one strong active program is on robotic fish.
RoboFish? Really?
This is a facility that we use for studying the design and the performance of robotic fish. And I guess we can put that in water.
So, robotic fish, that sounds interesting. But there is much more behind this than just wires, circuits, and motors.
Can we take these things down to real applications, meaning can you use these robots that are behaving like fish in some sense to scout out the environment, for example, and collect information and do such things through collaboration?
We do experiments on how, the speed of it and how it turns, and we want to put sensors on it, so eventually we could deploy it in lakes.
We're starting to explore things like environment monitoring.
We're gonna put this, kind of hold this fish in the river and take a picture of it.
That feels like perfect weight, about like a real fish.
One idea is about their application is to mount different sensors potentially on these things, let them patrol the water environment. That way you can get information like oxygen level, dissolved oxygen level, temperature, salinity, and even turbidity and all kinds of environmental factors.
So, what could a school of RoboFish accomplish by swimming around in your local lake or stream?
You can monitor the drinking water supply, make sure nothing is suspicious or in the water. So really you can talk a lot of potential applications in environmental science, in public safety, and even in defense.
These robotic fish, fitted with sensors, could swim around a pond or river and monitor the water quality. Some of the other applications involve monitoring oxygen levels at fish farms and even surveillance of our seaports. Is there anything that these fish can't do?
Our fish aren't submersible fish right now. They just swim on the surface. And in this particular fish, the top is removable, so it's not permanently sealed. So once water gets in it, it'll just fry the circuitry.
But Chabot and his team are working on that. They're in development of a robotic fish that can submerge, loaded up with sensors that will keep us safe. Let's just hope they don't become self-aware and take over the world.
Every science fiction movie that I've ever seen, that's when the robots take over the world.
Right.
Are you concerned about that at all?
Well, not at this point. Not at this point.